yes, it's gorgeous. It really is. One of the things I missed when I lived in San Francisco was that we never got thunderstorms. One night, very late, many, many years ago, a front rolled through across the Pacific, and we had thunderstorms, and everybody got up. The whole city, Berkeley, Oakland, everybody waked everybody. They called everybody, and there was a huge all-night block party as people watched lightning and rain and heard thunder.
Well, I don't have block parties here, Richard. We have it occasionally. This is the month when we get it. We have a 100-foot tower in your backyard during a big thunderstorm. You don't go observe the view. Well, you do, but you sit out there and mostly pray. Don't you play tower?
I know the feeling. Yeah. Remember, I make 1,000 feet, and I have electronic gadgets like you do.
Yes.
And you don't want something to hit. Actually, when it strikes close, the amp is very impressive.
I know.
It's very impressive. So we were talking about life and possible life on Mars, and this Wickrama Singh thing, life, the little bacteria in the stratosphere,
yes,
and the thing, possible little mini comets, in fact, is tied in to the potential solution to the mystery of Mars. Back to this, folks. You got to stay tuned,
right,
because later in the evening we're going to tie these two things, which I did not know were connected, back to what we think we have now discovered.
All right. We're also going to have some very interesting photographs, probably just after the top of the hour on my website. So stay tuned for that. Just stay by your computer. We'll tell you when we're ready.
I remember when we could do radio and not have to worry about the pictures.
Well, look, there's nothing like pictures to punctuate whatever you're saying, Richard.
No. I mean, I'm obviously, tongue in cheek here, because we have developed through, your show, this incredible combined medium.
Yeah.
Remember, we did the first internet radio simulcast.
I remember. They absolutely should be combined, and I will continue to combine them as long as I'm here, increasing that every time I get an opportunity. Anyway, then there's this gas thing on Mars. I want to understand that controversy.
Well, this segues nicely, because, as I said, in 76, there I was at the JPL with Gene on my right, Eric on my left, 1,500 friends, watching Viking land. Now, Viking was built by NASA as the search for life on Mars, for a good reason.
Right.
The idea was you'd land this DW-sized spacecraft by remote control, because it's 8 minutes away by the speed of light, so there was no hands-on law. We literally were getting our data 8 minutes after everything had happened, so it either happened or it didn't. There was not a damn thing anybody could do about it. So we get the pictures, and then a couple days after, the little hoppers in the top of the spacecraft opened up, and an arm reached out, kind of a remote robotic arm, and the computer, under prestored ground commands from JPL, picked up a soil sample, brought it back, and then dumped the soil in the containers on the top of the spacecraft, kind of equilibrating, between first and the second and third experiment. Everybody got their samples, and then the instruments went to work. Now, what NASA had done is to go to TRW, which is a major aerospace company in Southern California, and they had built into about a cubic foot of space. Cubic foot is about what, the size of your monitor, maybe?
Right.
They had built an incredible, complex, remote-controlled biochemistry laboratory, 1 cubic foot, and set it 40, 50 million miles over Mars and set it down on the surface. And the idea was that this laboratory would sniff and sample and, examine the stuff going on in the 3 chambers and report from 3 different experiments whether there were any microbes in the soil.
Let me represent the average person now. That was a long time ago, Richard, and as far as I knew from then, there wasn't much to be announced. And now, all of a sudden, in 2001, we're getting some sort of announcement about something they found then. I just don't get it.
I love the way you mentioned the number 2001. Because there's a lot of things happening this year that I think it's kind of time that they happen.
Well, okay, but if they answer my question, I mean, why are we hearing about this just now? Is it some...
Well, according to the story, I was there, so I can tell you what happened at the other end of this pipeline 25 years ago. The 3 experiments did their thing, and all of them reported positive results on it. Every experiment that NASA did in this gadget said there's life on Mars. And those of us who were watching were absolutely dumbfounded, because experiments had been designed to look for opposite kinds of chemistry. And you couldn't have a positive registering life if there was opposite stuff going on the soil. In other words, it was like having a yes and a no answer simultaneously. And then there was a fourth experiment called the GCMS, which was basically designed to measure organics, to measure the dead body. On Earth, when we have life going on, we have hydrocarbons involved. We have hydrogen, carbon, nitrogen, things like that. And there's organic residues left over from dead bodies. This gadget was designed to sniff the soil down to the parts per billion level, that's with a B, and detect the residue of life, the dead body. Well, it didn't detect any dead bodies. It didn't detect any organic chemistry at all. And so NASA officially said that the three experiments which had, quote, positively detected life couldn't. That in fact it was what they called funny chemistry, having to do with a very weird surface, a highly oxidized, a super oxidized surface of Mars, given its peculiar history and environment. And in fact, it was only chemistry, it wasn't life, and everybody go home and nobody got excited. Well, one guy wouldn't go home. His name is Gil Levin, Dr. Gilbert Levin. I think I've discussed him a couple times on your show briefly. And he ran a company called Biospherics Inc., and he and his co-investigator have insisted for 25 years that their experiment, in fact, did detect microbial life in the soils of Mars, and NASA simply changed the rules in mid-game.
Why?
Well, that's a huge political discussion, and I don't want to kind of get off into politics.
All right, okay.
But what he has been doing is he has been pursuing every possible loophole to try to counter the official NASA position that we didn't discover life, or his experiment didn't discover life. Now, his experiment is called the labeled release experiment, and the theory was as follows. You basically put the soil in the chamber, and in his gadget, his little vial, you then dropped in a little nutrient, which was called affectionately chicken soup. It was actually a complex organic compound. And the idea was that the little beasties, the little microbes in the soil, if they were there, if they were alive, they would glom onto the chicken soup, they would eat it, and they would then respire, they would outgas, exhale carbon dioxide like microbes do here on Earth. Right. The difference was this chicken soup was laced with radioactive carbon-14. So as they exhaled their carbon dioxide, the gas would float up to the top of the chamber, and there was a little radiation detector up there that was supposed to measure the amount of radioactive carbon locked up as CO2. Okay. And when everything worked as advertised, I mean, instrumentally engineering this was an incredible tour de force. I mean, we did an incredible job in 1976 because everything worked. The only thing that didn't work was the interpretation, the scientific reception of what these gadgets were trying to tell us. Because what happened in all these experiments, but particularly in Levin's experiment, is that the labeled release thing worked. The gas came off, CO2. The radiation detector measured the carbon-14, which is how it knew how much gas was coming off. And over the next 9 weeks, Art, 9 weeks, that's 2 months plus 1 week, right? This thing continued to evolve. Now, they did controls. They then dumped it out, flushed it out, put new soil in, started it up again, they got the same reaction, and then they raised the temperature to about 160 degrees centigrade, like an oven. And that was supposed to kill the microbes, to sterilize them. And you would then see if you had any reactions after that, right. And the reactions went away. Poof, gone, bang. Flat, dead, line.
So then why didn't they announce, oh my God, life on Mars?
Because they couldn't detect in that fourth instrument any organics. And they claimed that was their control, and that if they couldn't detect the organic residues of little microbes, then there couldn't be microbes, and therefore there couldn't be life, and there had to be some kind of weird oxidizing chemistry. Well, Levin spent 25 years, a quarter of a century, almost as long as I've been pursuing the Cydonia thing. He and his team have been pursuing the idea that they did detect life, that we didn't want to admit it for whatever reasons, and he's been up against a very stiff uphill climb. In 1999, a guy named Joseph Miller, who's a neurobiologist and a circadian rhythm expert, You know what circadian rhythms are, right?
Yes, I do.
Yeah, well, for folks who don't, every biological organism appears to have an internal clock. And even when you isolate organisms ranging from microbes to bacteria to mussels to frogs to us, in the dark, away from light and dark, there is this internal clock, right, which tick, 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 and seems to somehow know the planet's rotation, the day of the planet you're on.
Sure.
So this guy, Miller, somehow had a chance to look at Levin's data 25 years later, back in 99. And he was struck by the fact that as the gas came out and was measured by the radioactive detector, it showed peaks and valleys. Ding, ding, ding.
Right.
And they looked like they corresponded to the Martian day. So he said, oh my God, maybe. So he went and asked, he said, get me all this Viking data. And I said, Dr. Miller, we kind of have a problem there because we've lost it.
You lost it?
They lost it. And so they scurried around and they finally found, he thought it was on one of the NASA websites, like everything is supposed to be out there somewhere.
Yeah.
It wasn't anywhere to be found. Now he's assuming a benign interpretation. You know me. I take there maybe less benign, but let's not get sidetracked. He finally got some people to get him the original magnetic tapes. And lo and behold, they had been programmed in an arcane machine code that was so primitive compared to what we're using now that the programmers had died. There was no way to get the data off the tapes. So then he gets hold of Levin. Fortunately, Levin had made paper copies of everything and was able to supply him with this. And together, over the last year or so, it's 2 years, since 99, 2.5 years, they have been working to restore this data, and Miller has been subjecting it to the kind of controls and statistical analyses that his profession brings to it, neurobiology and circadian rhythm studies, right? And last week in San Diego, at a major conference, he published a result which is pretty astounding, because he claims that what Levin has found is evidence, unequivocal evidence, of biological activity in the soil which exhibits the circadian rhythm of the 24.66 hour Martian day. And
All right, again, on behalf of the normal person, why should we care whether there is microbial life on Mars right now or not? I mean, basically, it's a wasteland. If Mars once was alive, as we understand major life, it is not now. And if there is microbial life there, what difference is that going to make to us?
Well, in the context of your discussion with Stephen last night, and in some of the things you were doing in the first hour, we should care because planets are not immortal. Planets can die. And in this incredible, vibrant living world right next door, and something terrible happens, or a series of something terrible, and we could be inadvertently doing stuff to our world that would bring on the same catastrophe.
Yes.
We gotta know that. Because we gotta be able to take another road. We gotta be able to take the left fork and not the right fork.
I see that clearly.
The other thing is that if there is life on Mars, then it presumably had a history. It had an origin, it had an evolution, and if it's there now, it exists in its current condition because of all the things that happened to it.
Yeah, I think certainly it's fair to say if it once had the water on it that we think that it had, or even that we know that it had, then there could have been big life.
Oh,
it could have been, and if it was, I mean, you're absolutely right. We need to know for that reason. In addition, there are a lot of people talking about the possibility of terraforming Mars in case we might need it. So I can see all that.
And of course, there's, is there a heart that is so dead that it doesn't want to know if it's alone? Because as Carl was so fond of saying, if we find so much as a microbe next door on Mars,
sure,
it means the galaxy, the universe, is teeming with life.
True.
And of course, it would back up with the science, the claims of all the UFO people that there are folks visiting, and claims like us that there might have been an ancient civilization there, and it would be an extraordinary, even to find a microbe. But what you're going to hear tonight as we get through the rest of our mystery is that we're thinking now there's a lot bigger stuff than microbes. And what's amazing is that what we think may have happened to Mars may have left only the microbes alive. Everything else that we think could have been there may now have been deceased.
In other words, everything larger than a microbe
is gone
deader than a doornail.
because of what happened to Mars and what could happen to this planet. It comes back to what do you do about your home? How do you protect life and limb and home? And so looking at Mars is not an academic exercise. It's a cautionary tale in if you don't do this and this and this, maybe, but for the grace of God, you'll go that way too.
Well, Richard, we do know there's a long history of probe failures to Mars.
Incredible, statistically weird failures, yes.
Is it so weird that there is some external force at work, whether it be earthly or otherwise, in your opinion?
Well, as I said on the fact show, my bet is that if there's any weird forces, it's political. Its missions don't die, they're just kept from us who are paying for them, because they find things that those guys don't want us to know until the right time.
Well, going to Mars or any other planet is a chancy thing to do, and there are going to be failures, but there does seem to be a very disproportionately large number with regard to Mars.
Compared to places we have gone, which are a lot more hostile, like when you go towards Venus, toward the sun, it gets hot.
Yes. Okay.
Electronics don't like hot, okay?
Right.
They like cold weather. When you go to the big planets like Jupiter, Saturn, they have huge radiation fields, and we got a Galileo, which we're going to have to go out there and beat to death with a stick, because it's just going and going and going. In fact, they're going to dive into the atmosphere in a couple of years to permanently get rid of it so it won't, clutter up the radio channels and possibly collide with Europa.
Actually, it's diving in with a bunch of plutonium, isn't it?
Yes, just a little bit, not a lot. It won't do anything. That's not. Don't even go there. Right? That's not a real problem. The point is that technology in space works extraordinarily well. We have Pioneer spacecraft that were sent to Venus back in the 60s that are still alive 20, 30 years after they were launched.
That's true.
The fact is that going to Mars, which is a relatively benign place, it's right next door, it's just a little further from the sun than we are, the Russians and even us lately have had an extraordinary series of, quote, failures, boys and
Well,
girls.
it really should be the easiest place to go short of the moon.
That's right.
And it's really the hardest. Richard, hold on. We're at the top of the hour. We will be right back.
I've been drifting on the sea of heartbreak, trying to get myself ashore for so long. For so long. Listen to the strange story, wondering where it all went wrong for so long. So long. Hold on. See what you got. I'd like to see you live. Never make something as you ride the super apology. Everybody else will surely know. What you love to.
Wanna take a ride? Well, call Art Bell from west of the Rockies at 1-800-618-8255. East of the Rockies at 1-800-825-5033. First-time callers may reach out at 1-775-727-1222. The Royal Guard line is open at 1-775-727-1295. And to reach out on the toll-free international line, call your AT&T operator and let them dial 800-893-0903. This is Coast to Coast AM with Art Bell on the Premier Radio Network.
Certainly is. Good morning, everybody. We've got the visuals up now to go with the discussion we're about to have. Let me tell you how to get to them, all right? You go to artbell.com. And when you get there, you go to Program over on the left-hand side. Simply go to Tonight's Guest Info. Repeating, Tonight's Guest Info. There you will see the name Richard C. Hoagland. The first thing you see is images, Mars illustrations for tonight. Click on that. There are going to be 9 illustrations there that we're going to be talking about. So if you start up the web right now, you'll be able to follow along with us. Again, artbell.com. Go to program, tonight's guest info, and right under the name Richard C. Hoagland, you'll see the images for tonight. Click on those and follow along with us. Richard C. will be right back. Stay right where you are. All right, back now to Richard C. Hoagland. Figure number 1, the first figure is sort of an introductory photograph, I suppose. It's a photograph of Mars. And boy, is it a good photograph of Mars. Richard, that's really a pretty picture of Mars.
Isn't that gorgeous?
Yeah, it's gorgeous.
Well, it's not a photo, it's a piece of art.
Oh, well, that's why.
And it's a piece of art as Mars may have looked many, many, many hundreds of millions or even billions of years ago.
Yeah, I thought it looked a little blue.
It's very blue. And there's water running down Valles Marineris.
Yes.
There's an ocean on the left
Yes.
toward Olympus Mons. There's blue sky. There's wavy scattering. There are clouds. It's warm. It's wet. And this is part of the mystery. What we're going to talk about for the next couple hours is the work that I and Mike Barrett have been doing for about a year, quietly with a number of other colleagues, to try to put together all the pieces of the puzzle ever since 71, since the first Mariner 9 images that told us we had a place that was maybe like the Earth once and was nowhere like the Earth now. I mean, the temperatures on Mars are extraordinarily cold now.
Well, can I ask about one more thing?
Sure.
The recent storms on Mars,
The dust storm.
the dust storms, I've heard from varying sources that the dust storms of the magnitude they're having actually shouldn't be possible.
That's one theory. It's an interesting theory. I mean, we know they occur roughly every couple of years when Mars comes around closest to the sun, and we only really get to see them when we're closest to Mars, when it's close to the sun, which happens roughly every 17 or 15 years.
These are monstrous storms.
Well, you got several things working for you. You have a very thin air, thin atmosphere.
Right.
You have an extremely dry surface. I mean, it is bone dry.
Right.
So when you store up dust, even in a thin atmosphere, there's no water to wet it. There's no wetting agent. It doesn't stick together. It's been dry for many, many millions of years and getting drier.
So kind of like out here where I live, so dry that when the wind blows, it picks up.
Everything.
Yeah, that's right. All right.
Except on Mars, it picks it up and there's no precipitation falling to bring it back down. There's no nucleation, which would make it bigger and clump together and make it fall.
Yeah.
So that's why when Viking landed, we were astonished to see that the skies look pink.
So then it's it's how close it gets. In other words, when it warms up, when it's closer to the sun,
Mars' orbit is not circular like the Earth.
the energy is sufficient to get it going.
It's sufficient, and plus you're tilted. That hemisphere, the southern hemisphere, is tilted toward the sun, so you get an enhanced effect.
Okay.
On Earth, we have a tilt, 23.5 degrees. Mars is tilted 25 degrees. The tilt creates seasons, right? On Earth, we're closer and tilted toward the sun in the winter in the northern hemisphere, so the two things kind of moderate. Even though our orbit is pretty circular, it's not exactly a circle. Mars is very elliptical. It's quite elliptical, egg-shaped. And so you can get millions of miles closer to the sun on Mars, and in the southern hemisphere summer, you can the northern hemisphere winter. So the summers on Mars are warmer, and the winters are colder by a lot than they would be if the Mars orbit was circular. So the dust storm that we're seeing erupted from a place called Hellas, and like the one back when Mariner 9 went into orbit in 71, it quickly spread around the entire planet. So for weeks you couldn't see anything but dust.
That's right.
You got your telescope just at the wrong time, Art.
I know. Although it was really, I could clearly see the storms. It was incredible.
Well, I was watching before the storms. In fact, that was the night we were going to do the show, the night it was closest.
Yes.
And then you had to leave a little early.
Yes.
We had an incredible view and all kinds of neat, mysterious things that happened. But the view you see on the screen now, for everybody watching, on TV or on their computer, that is the view of what we now think Mars may have looked like hundreds of millions of years ago. And what we've been trying to do is to piece together the puzzle that would allow us to say some very certain things that have never been said before about Mars. And by the end of the evening, we hope to be able to tell you how we got there.
Okay.
This all comes down to water. it all comes down to where does the water go. That's why Mars Observer and Mars Surveyor were sent.
Right.
Because NASA, since 71, has seen these incredible evidences of ancient water, vast canyons caused by rushing floods and streams and tributaries and ancient rivers, all bone dry now, all sitting there under their, 100th atmosphere of Earth.
Yeah, what is life? What is life?
And water is definitely connected to life. If you don't got water, you don't got anything.
Right.
So where did the water go? Well, about a year ago, when we finally got our first sets of pictures, this is now the second picture down, right? In July, a little over a year ago, we published on Enterprise a photograph right after the NASA press conference on water. Remember they announced they found evidence of arroyas,
I do indeed.
of erosion that looked like it could have been maybe 1 million years ago.
Sure.
Could have been yesterday, but there was no liquid water. But we found some images, and this is one of them, which show things, dark, streaky stains
Yes, indeed. Dark. Indeed dark.
that appear to, for all the way, they go from high level stuff down to lower level stuff, downhill.
I see that, yes.
And you can see here several different versions. There's real dark ones, then there's lighter ones, then there's real light ones.
If this is moisture being represented,
That's what we,
and it does look like it's going downhill, folks. Look for yourself.
all right?
Inevitably, the darker, the further down you go, the darker it gets, indicating the water's cooling down below.
So this has been a mystery now for about a year. And we were the first to publish and claim it was liquid water. And here's the model we actually present on Enterprise of
Coming from where?
coming from underground. Coming from water that is being melted underground. Because remember, the temperatures refer to the surface, air temperature. As you know, living in the desert, that it can be relatively comfortable standing up, but if you put an egg on your sidewalk out in front of the house, it can actually fry.
Yeah, that's right.
So the ground can be warmer and can trap energy more than the air. The air is very thin on Mars, so the air temperature is very, very cool all the time. But the ground temperature can get up to 50, 60, 70, 80 degrees.
Mm-hmm.
Did you know that?
I had heard that, yes.
And this was measured by Lowell and guys with telescopes and now reconfirmed. So the ground near the equator can actually rise well above the boiling point of water. I'm sorry, the liquid point, not boiling
You
point.
mean the melting point of ice?
Exactly. In other words, about 32 degrees Fahrenheit.
Sure.
Now, the theory says, well, wait a minute. Even if you had water, as soon as it hits the air, it's going to evaporate. So if you have a liquid pool, it'll go poof. It'll disappear within minutes. But if you wet the ground from underneath, and the ground has certain properties, and we'll get into that in a minute, you might be able to have liquid water that would stay liquid, wetting the ground like a sponge. You know how you can wet a sponge from underneath and it seeps up through?
Sure.
It would stay liquid for hours or maybe even half a day before it evaporates, depending upon the kind of soil and where the water is coming from, how deep. So we looked at these last year and we said, holy, whatever else, it's liquid water. And as soon as we said that, NASA said, you guys are crazy. It's dust. These are dust avalanches flowing down hills, etc. End of discussion. And a whole bunch of people in the so-called anomalous community,
How do they know?
well, they don't.
Looking at the same photographs we are, right?
That's right. And we've had now geologists, we've had Ron Nix look at this, we've had a lot of other people look at it. There have been a lot of independent investigators, people like Efren Palermo and Jill England, who are two people I really want to cite tonight because they did some amazingly good scientific research which allowed us to create the paper that we have published in Enterprise.
Richard, you can even see in this photograph some of these downhill shadings, which are almost dried up. If you imagine it's water, and at the very bottom, it's darker, as it certainly would be if water, if it was liquid.
It's cool under gravity, and the bottom has more than the top.
No question about it.
Flying slower.
Yeah.
Now notice that there are light ones in between.
I do, yes.
Okay, everybody who's ever lived in the Midwest or in the mountains knows that you have a terrible problem, the so-called bathtub or bathroom sink stain problem, which is caused by calcium carbonate,
That's right.
or any one of a number of other minerals.
Right.
If you were to have mineral-laden spring underground, soaking up through the sand and the dust, and wetting it and looking darker because it's wet, and then drying, What you would get as a residue after that process had gone would be the minerals of the earth.
Right.
You get the white stuff, and you can
That's
see
right.
some of these streaks now, instead of being dark, they're light.
Yes.
Well, we were pretty convinced that we were looking at liquid water. And then other people picked up the cudgel. As I said, Efren Palermo put up a website, and he started culling through thousands of Mars images, or the stains, we call them.
Yeah.
Stains, because they're dark stains, right?
Yes.
And he's got an incredible website, which is linked to Enterprise, if you go down a little bit, where he mapped, he basically goes all over and he put up images and images and images. And finally, I got together with him this past spring, and I said, Efren, have you made a map, a global distribution of these images?
Right.
Because if we're looking at water art, our idea was it should be around the equator, because that's where it's warmer.
Sure.
If it might even be seasonal. And if you look over enough of Malin's pictures covering a couple of Martian years, you may be able to decode all that. Well, he set up a global Mercator projection, and he involved a very bright young gal named Jill England, who is a statistician. She is a whiz at mathematics. And what she has done is gone through, get this, all of the 70+ thousand images from Mars that Malin has given us,
Right.
and done a statistical analysis, a first-rate statistical analysis, which they, by the way, have put into a paper that they're publishing at the Mars Society conference in, I believe it's, in a few days in Denver, the annual conference of people who basically want to send manned missions back to Mars.
Yes.
The paper was accepted, and what it shows is that the distributions of these stains is very, very weird.
It is. I'm looking at figure 3 jumping out.
That's it. Jump down now to figure number 3.
Yeah, okay. And
Because
we're looking at
Efren's map.
we're looking at 180-degree difference from the
That's
planetary
right.
point of view, correct?
That's right. You've got a big cluster of stains in one place on Mars, and then if you look at Mars as a globe, and we'll get to that in a moment, 180 degrees away on the other side of the planet
Oh, beacon.
are where the rest of the stains are.
Yep, there they are.
And there's nothing in between.
And you've got the code of the red dots indicating stain images,
That's right.
the yellow dots indicating light stain images, and the green dots indicating
This is
non-stain.
Efren and Jill's coding, but as I said, we suggested that he do the map, and this became the central mystery all spring into the summer. We've had all kinds of, discussions among ourselves.
Yes.
What in the world could be causing this distribution? Now, this distribution has a name. It's called bimodal distribution.
What does that mean?
Bimodal means it's got two poles.
Oh.
It comes up in two places.
Right,
Bi means
okay,
two, like bipolar
Sure,
distortion.
sure.
There is no way that these can be dust. Because dust, the airs of Mars flow all around the planet. You have global dust storms, boys and girls. That's what we just stopped discussing, right? So how can you be falling down, steep cliffs and other places on Mars only in two areas that are 180 degrees apart? So I looked at this, I looked at this, I looked at this.
You can't. It's water.
No, it's got to be water. Well, let's put it this way. It has to be a fluid.
A fluid of some sort.
It might not be, if you want to be very scientific.
Well, what is a good guess? If we
Water is a very good guess.
think there was a lot of water on Mars, then it follows there could be obviously could still be water below the surface.
But as we said in our original note last year, those dark things could be oil.
Well, it could be.
They're so damn dark.
It could be.
Tommy Gold, you know Tommy Gold?
And the way it's going, in about 35 years, it'll be financially worth bringing oil back from Mars.
George, you hear that? You want to drill in Anwar? I got a place for you.
Yes, indeed.
Long pipeline. Very long pipeline. Anyway, Tommy Gold, who is a brilliant astrophysicist, he actually was the one who coined the term pulsar and neutron star.
Yeah.
He has proposed that the oil on Earth is not due to organisms, little biogenic things, ancient guys,
It was dinosaurs. Yeah.
old dinosaurs, we're digging up the T-Rexes and putting them in our gas tank.
Right.
He is claiming, with some reasonable evidence, that the production of oil is not biological, but it's chemical. And it involves hydrocarbons, that those are made, naturally as opposed to with life, and that any planet with enough chemistry should have deep layers of oil under its surface, even if it never had life.
Well, then shouldn't there be here on Earth more oil forming underground?
Yeah, but it takes a long time to form.
Oh, well, I understand, but shouldn't they be able to see, even at the macro level, some development of new oil?
It would depend on where you're drilling, and in other words, how would you know if you're drilling into a pool in sediments that isn't a biogenically formed?
Well, shouldn't they see something in process, in you know?
Well, Gold's theory is so controversial, and it has not been really tested yet. I think they tried to test it in the Baltic Sea.
I'd be more comfortable with the fluid idea, the water idea, even than oil.
Well, you have to be kind of objective here and say it could be another fluid. Back down to the map, all right?
All right.
There's a map. The map is gold. I mean, this is where Efren was hopefully listening tonight, because we've not told him what we figured out from his map.
All right, everybody. For those of you that don't have computers, the two areas, 180 degrees apart at both poles of Mars, are just filled with these red dots that would indicate some sort of stain images, serious stain images. Elsewhere on the planet, you've got mostly green, which means non-stain images. It's just impossible. It's absolutely impossible. It probably is water. Okay, I'll give you that, Richard.
Well, the thing that is conclusive that it's got to be a fluid and most likely water is the next graphic down. Because I'm looking at this, and I'm suddenly thinking, oh my God, what would give you an unmistakable bimodal double pole 180-degree signature? Tides.
Tides, indeed, yes.
If you look at that diagram, this is listed from a guy named Michael Payne.
Yes.
And what people don't realize, even though we live on Earth, even if you live near the seashore, most people don't realize that we, for a very good reason, have 2 high tides a day. I mean, living in a desert, you wouldn't know anything about this, but presumably you're out in Okinawa or places like that, you watch the ocean.
Oh, yes, Richard, I've watched the ocean from time to time.
Tongue-in-cheek. The reason we have 2 tides is because the moon is the culprit here. The moon raises gravitationally a lump of water on the one side of the Earth. That's where you have 1 high tide. But what most people don't know is that on the other side of the Earth, exactly the same moment, you have another high tide,
Right.
180 degrees opposite. And there's some funny little physics, and that diagram explains it if people want to go and kind of study it. But, we don't have to get into the details, but on every body where you would have tides.
Yeah, actually, I would like to understand that. Hold on, Richard. He's right. We have a high tide on this side, which is facing the moon. I understand, I think, the physics behind that, but I don't understand the physics that would create high tide on the other side of the Earth, which is not seeing the moon, or the influence from the moon. We'll ask about that. I'm Martel. This is Coast to Coast AM. Good morning, or afternoon, or evening, or whatever it is, wherever you are.
Want to take a ride? Call Art Bell from west of the Rockies at 1-800-618-8255. East of the Rockies, 1-800-825-5033. First-time callers may reach Art.
Good evening from New York. I'm Chris Hayes. Well, the Republican Party is stuck with Donald Trump. They won't say that publicly, and they